everyone, and for our mobile app project, we chose to develop Collision Guard app. My team members for this project is that I work with Abhinav Kumpella, and I'll start talking by giving you a quick overview of our project. So the main goal of our project is to enhance and expedite emergency responses in the event of automobile accidents. Our aim is to address the critical issue of delayed emergency response times, which can be a significant factor in preventing fatalities after accidents. To achieve this, we have developed an app that utilizes the built-in sensors of mobile phones. The app detects collisions, and in an unfortunate event of an accident, it sends notifications to both pre-designated emergency contacts and local first responders. So the key features of this application would be a collision detection system. We developed a model for accurate collision detection using accelerometer data. Geolocation service. This app integrates the geolocator API to provide precise GPS coordinates of the accident location. Emergency notification system. In case of an accident, notifications are sent to saved emergency contacts with real-time location details. And messaging feature. Alerts are also sent to ensure a swift response. So, talking about the problem statement, we're trying to focus on the significant issue of delayed emergency response times, which can often lead to fatalities after automobile accidents. To address this problem, our project provides a mobile application that leverages smartphone sensors to detect collisions, automatically notify emergency contacts and first responders. So this particular application has multiple screens that I'll be talking on later. And the target audience for our application would be smartphone users, anyone interested in enhancing their personal safety. Drivers and commuters, individuals more prone to accidents who can benefit from immediate emergency responses. Families with teen drivers. This app provides an added layer of security for young drivers. Students and emergency responders. A tool to provide a real-time incident information. Now, talking about the design. So this is the home screen of the collision guard. On the screen, you can see accelerometer values that are displayed as three tiles, X, Y, and Z coordinates. And then on the bottom, there's a tile that actually shows the speed of your car. At the very bottom of the screen, there are two buttons. There's one that says start detection, begins monitoring for potential collisions, and then the other button actually it is basically the view driving graph, displays real-time graphs for accelerometer data and speed. On the right side of the screen now, you see the graph screen. So when you start detection, the app will display a screen with real-time X, Y, and Z accelerometer graphs. A graph showing the speed of the car. At the bottom, you'll also find navigation buttons for the home page and settings page. And next comes the page where an accident is detected. So if the app detects a potential accident, it prompts the accident screen, which includes a 15-second timer. If you're safe, you can press the I am safe button within 15 seconds to cancel the alert. If you don't respond within 15 seconds, the app automatically sends an emergency message to your saved contacts. The message includes your latitude, longitude coordinates, ensuring responders can locate you quickly. Now, talking about the human class time. Here's a quick overview of the backend flow of our app as represented in human class diagram. When you start the app, accelerometer data is sent to Firebase. The data is processed by a collision detection model. If the model predicts no collision, the app continues monitoring accelerometer data. If the model predicts a collision, it retrieves GPS data and checks the car's speed. If the speed is not zero, the app continues monitoring for further updates. If the speed is zero, the app prompts the 15-second timer. If you press stop within the timer, the app resumes regular monitoring. If the timer runs out, an emergency text message is sent to your saved contacts within your GPS location. Now I'll be talking about the machine learning aspect of this application. So we have utilized machine learning so that the application can detect if an accident has taken place or not by analyzing the accelerometer values that have been given as the input to the model. So in order to train the model, we have first collected data by ourselves by using the accelerometer sensor that is available in the phone, and collected data where we have taken accelerometer values in X, Y, and Z directions. And the plots that we see right over here is the data distribution, or you can say the values of the accelerometer in x, y, and z directions at a particular duration, where the sudden spike shows that the acceleration has been done in a certain direction. So anything that's above or in the positive side says that's a positive acceleration, and anything that's in a negative value is more like in negative in the opposite direction. And a sudden spike can be a case where an accident has taken place. Once the data has been collected, we actually processed it to make sure that the data is clean before it's given to the model for training. So we performed stuff like balancing the dataset to make sure that there were enough classes or enough instances of accident taking place and enough instances where there's no accident taking place, and made sure that everything was of the same type to maintain consistency in the dataset. Once the pre-processing has been done, we have fed the entire dataset into a machine learning model for training purposes. So in this case, since we're trying to classify whether an accident has taken place or not, we used a logistic regression model. So a logistic regression model is simply like a binary classification model that says whether an event has taken place or not. So to give an exact definition, it is a statistical method used for binary classification, which means predicting the probability of an instance belonging to one of the two classes. So here, if the outcome is 0, that implies there has been no accident. And then when the outcome is 1, that implies, okay, the accident has taken place. And now a message or an alert has to be sent out to the user saying if it doesn't respond in 15 seconds, and then an SOS, and it'll be reaching out to its emergency contacts. Now, the model has performed quite well with an RSE score of 0.8 and with recall and precision scores of 0.8 as well. So, with a good enough precision and recall score, we can say that this model has been performing quite well, ensuring that the false positives and false negatives are minimized and making sure that the user can be safe in most cases.
Welcome to our project demo. I am Abhinav and I will be giving the demo today. So first up, let's open the app. So we have an authentication page where you can enter an email. If the entered password is wrong, we also need a test case where it says it's an error and you have to try again. And if when it's right, you can just sign in and you get to the home screen. So on this home screen, we have few very important widgets which I'm going to go through. The X, Y, Z, all of these widgets contain the real-time accelerometer data from the phone sensors, and this is a speed and this is an animation for the speed. So in case you're in a car using this app, this speed animation goes up according to the kilometer per hour. And we have two buttons. We have a start detection button and we have a show driving graph button. And another screen we have is a settings screen where the most important settings we have are contacts, app permissions, and logout. So when we look at contacts, we come to the contact screen, and here we can choose to add more contacts or delete a contact also. For example, I can add all of my teammates names also into this. For example, Sri Bhuvan, and I can enter a random number and I press add. Same thing, I can add Subhash, another random number, add, and then we have Aparna, another random number, click add. So we can also have a test one just to see if the delete function works. Add. As you can see, these are all the contacts we added, and we can also delete a contact by just like sliding it to the left. And all of these contacts are stored on Firebase, and all of the details like are mapped to the individual login. Another setting we have are app permissions, where we get to edit the app permissions, so we can choose to like remove any permissions for the app you have already set up. And then we have a logout. So coming to the demo, once we click start detection, the app starts detecting the sensor values. So I hit start detection, and if you see on the right side, I have a virtual phone. So if you see, as I move the phone around in this axis, which is the Z axis, you can see the Z value is changing. As I move it up and down, you can see the Y value is also changing. So along with all of these values, I can also like show the graph of your driving history. So as you can see, these are all the values you have been recording for the y-axis, and these are all the values for the z-axis. The phone did not move in x-axis, that's the reason it's a straight line, and we cannot simulate speed on the emulator also. We also have a choice to export all the data we generate. So I hit start detection again, and if we simulate an accident, which is when, like, imagine you're driving fast and the phone is going and it comes to a sudden stop, you see, you get this screen. It says why you're an accident. If you're not and you're just braking very hard, you can click I am safe, and it will redirect you back to the home screen. All of these XYZ values along with the speed values are being sent to the TensorFlow Lite model, and the predictions are coming out of it. So depending on the prediction, it decides if it should show the accident screen. So again, if you simulate the accident screen again, and we let the timer run out. Okay, so a 15-second timer starts as soon as the app opens up. This gives the user some time to decide if the emergency contact should get a text message or not. In case it does not respond, as you can see, it says an emergency message has been sent to the emergency contacts. And if you look at the messaging app, we can clearly see that all the contacts have just added get a message, and as you can see, it gives you a latitude and longitude value so that they can reach out for help. If you see the time for the message, 12:55 a.m., and if you see the time on top, it's the same. So these messages have been sent just now. And yeah, the last one, log out. So as soon as you click log out, you're logged out of the screen and you have to log in again. You can also sign up and create a new account. So this is what our project is about, and we've used geolocated sensors, we use machine learning in the project, we use Firebase real-time database, and we used onboard sensors in the mobile along with all. So one small limitation we have for this app is that this only works if the app is in a certain position. For example, you need to place the app on a phone holder in your car for it to stay in that particular position. So for that, you have to rotate Y by 90 degrees, and then you use the move function to move it around. Thank you.